go ahead and get this fired off. Good morning, good afternoon, good evening, and welcome to the Rise Up podcast. My name is David Schultz, and today we're going to be talking about the Unified Namespace, or UNS for short. And the reason why I put this together is that there still seems to be some confusion, or we think we know what it is, but we're not sure exactly what it is. So the intent here is that we're going to try to socialize and define what a unified namespace is. As I was talking earlier, I spent the weekend about 3 hours with some people, and we were just hashing it out. And where we landed is the unified namespace is an approach for an event-driven architecture that includes a pub-sub technology like a broker and some sort of data ops tools that allows us to create data models and publishes and subscribes those data models through some kind of defined topic structure. That's where we landed. So hopefully by the end of this podcast, we'll be able to gel around maybe a little bit more clear definition. But with that, so I am now today joined by three very well-known people within the industry. I would call them the experts within Unified Namespace. They all have different approaches to it. So let's go around the room real fast and make an introduction. And if you could just briefly just describe when someone asks you what is a unified namespace, how do you describe that? So, Aron, we'll go ahead and start off with you.
I think you did a great job, David. I think I'll just steal yours. But yeah, so Aron Semle, CTO at HighByte, backgrounds in industrial manufacturing probably for the last 15 years. So started at Kepware back in 2010, I think. Time flies, but then PTC and now onto HighByte. So yeah, if I had to define unified namespace, I think the definition you gave right now, David, is probably really good. Report by exception, real-time data, single source of truth. And I think the other folks will get into that. It's nuanced, right? Where the confusion is, it's part of the magic of it and the problem with it. But looking forward to the discussion. Yeah,
absolutely. Thank you. Welcome, Aron. Jeremy.
Yeah, I'm Jeremy, co-founder and CTO of the United Manufacturing Hub. And because most of our customers are mostly large enterprises, so when we go in with the United Manufacturing Hub, we do not only need to convince like one or two people, we need to convince hundreds of people when talking about the unified namespace. So what we like to do is we like to make things very, very boring. So, and by boring, I mean, unified namespace is actually nothing really exciting. It is just the applied IT best practices applied. So what is it for us? It's an event-driven architecture with message brokers. Very, very simple, very well known. So what is it thereby not? It's therefore not a database because it's not real time. It's also therefore not point to point. And then there are like some additions, some fine tuning around it, what people typically understand with unified namespace. But that is the core. And it's actually something very boring, and a lot of people and industries that already do it, they just don't call it unified namespace.
Sure, absolutely. And then Kudzai.
Cool, thank you, David, and thanks everyone. So yeah, my name is Kudzai Manditereza. I'm a developer advocate at HiveMQ. So I do all of the evangelism in the unified namespace. I'm also a founder of Industry4.tv, which is a media and education company. Run a popular YouTube channel and a podcast. And yeah, I mean, the unified namespace is quite a nuanced, right, topic, but like fundamentally is about that event-driven architecture behind OT, IT, data integration. But I find a lot of times that the explaining it in mostly in technical terms is it kind of like sometimes loses some of the audience and they still sense of what exactly that is, right? So I think it's more apt to talk about the unified namespace, at least in my case, as being that sort of like data platform for continuous innovation, right? So it's that's kind of like really for me, and I think we'll get a little deep into that. That for me is that platform that gives you all data, real-time access to all data from all parts of your enterprise, OT and IT, which then allows you to continuously innovate on top of that data without going through a lot of friction around it. So yeah, excited to be here and looking forward to exploring it some more.
Well, excellent. Well, it's great to have you here as well. So as I defined, it's this event-driven architecture. There's a broker. There are some data ops in there. So Kudzai, could you lead us off with talking a little bit about what is the role of the broker in this whole process? Why is pub sub so important to a unified namespace?
Okay, so maybe just to kind of like set the context here, it's kind of like important to talk about how do we arrive to this idea of a unified namespace, right? And what are the challenges really that we're trying to solve there? And I think that will help us paint a good picture of the idea of PubSub and the broker. So I mean, typically, ideally, what as a company is this idea of becoming a data-driven company, because then that helps address a lot of different data use cases that you might want to address for you to maintain a competitive advantage. So whether is it in energy efficiency, or EE, or whatever advanced analytics use cases you want to address. And about the unified namespace is that for you to address all these use cases, you need to connect directly to all the different systems on the shop floor and connect it to IT. So you've got this OT-IT integration whereby you have got apps that are connected directly to equipment. So each time you need to address a certain use case, you need to set up that connectivity infrastructure. So there's a cost related to that. For each use case, you need to set up a dedicated connectivity infrastructure, and there's repetition also involved there, and just the time it takes for you to bring special different sources up to your IT. It takes a lot of time, months, and even years. So the idea really of the unified namespace is to say you create that hub of information where you have all these connections already set up, and you have all this information already being pushed to that central repository of information that gives you that real-time snapshot of all the current event and state of your business without having to worry about the underlying connections, right? So this idea that you're pushing data from the edge into this central repository of information, and also from IT of information where you have got this common format data unified, and that is accessible through that single interface, right? So this is where the broker comes in. It acts as that platform that allows components or systems to connect from the edge and push data hub of information that then gives access to real-time events and state of your business. And what really makes MQTT or the broker ideal for this scenario is that you don't want to just push data like using just MQTT and using it as if you are using like a legacy protocol where you just like saying the topic is like say a tag name, right? You want to be able to organize the data in a way that it can be discovered semantically by anyone who understands the organization, the structure of the organization. So MQTT gives you that ability to be able to organize information using its MQTT topic namespace. So this really is the part that the MQTT broker plays in the unified namespace, being that source of real-time access to the state through a single interface without you having to connect to 1,000 different servers on the shop floor. Just by connecting to one broker endpoint, you get access to all the unified data, all the normalized data in a way that it has already been organized and it is being pushed using a published communication. I don't want to get in much depth about how or what PubSub really is, but I thought that's kind of like at a high level the idea of what the role that the broker plays in a unified namespace architecture. So you still, at the end of the day, need some components that help you get data out, and I think this is basically where Aron would be able to expand a bit on how do you like get that data out, and then how do you marry OT data to IT data within an MQTT hub of information.
So yeah, before we move on to Aron, just want to make sure that I understand the role of the broker. It becomes, or that the technology that is selected, it's around this event driven. but I need an easy way for edge devices or other systems that are going to instantiate that connection. So that's one of the first pieces of it is, edge data can connect to something rather than having maybe a server client, a technology that I have to go and find all these. It enables easy access for all that data to get there. Then of course, now it's that whenever there's new information, that's part of the event-driven architecture is as new information is available, I don't have to ask you for it. The pub sub will say, or it enables that new information. You just send it to me when you have it, and I'll be sure that it gets out there. Is that a pretty good synopsis of the role of the broker here?
Yes, it is. And also maybe just to expand on that a bit, this idea of edge-driven, as you perfectly mentioned, that you don't get a situation whereby applications are reaching down to the shop floor to ask for this data. Instead, it is pushed from the edge into the data infrastructure, and what that allows you to do is to really create this idea of a single source of truth, because all this data that you're currently viewing is the data that is actually being pushed from the edge, from the source of the data. So you could easily build your business model around it, because it's not data that has been aggregated through different layers. It's coming straight from the device at the edge into the data infrastructure. And also just the idea that you don't have an application that is polling to get that information. It means that whenever there's a network failure with PubSub, the edge component or the device is able to buffer that information and retransmit it whenever that connection is restored, which in any other scenario you'd lose that information whenever there's that break in connection. So this is kind of like really the importance of having that broker or PubSub architecture in a unified namespace.
All right, excellent. Yeah, I certainly don't want to overlook the importance of the ability to buffer data to ensure we're getting everything there. So I guess in that case, make sure that when you're choosing a broker, that you choose something that has that ability and all the technology will support it. So as you were talking, Kudzai, and you mentioned that. Oh, go ahead, Jeremy. You had something?
Yeah, can I add maybe a little bit more scientific explanation? We tend to go a little bit more theoretically on a lot of things. Just 1 or 2 minutes. One of our most popular blog articles here, I'm sharing the screen, where we actually compared different MQTT brokers through it, and we only got 2 cease and desist letters for that article, but it's still online in the original form. And in the introduction, we try to give a more scientific way on why you need a message broker. In an industrial IT system, or in general in a system where you process a lot of data, you have always multiple building blocks. You cannot do everything in one application. And in order to connect those building blocks, there are, now thinking like top down, there are only 3 options on how you can do it. You can send it through databases. That's the first thing. So you have all the PLCs, they all send data into a database. And then you can do some batch processing on it. But as soon as you chose that architecture, a lot of historians, for example, are going, this is the standard historian approach. You cannot do anything with real-time data anymore. All this stream processing, so data comes in and you change the color of a traffic light, whatever, within a second or half a second. It's not possible anymore. The other way on how you can connect those building blocks is through service calls. So point to point. So you do a lot of point to point connections, and it's actually a fair and reasonable approach. However, in manufacturing, all of these blocks tend to stay there for like 10 years. Google, they will just, Netflix, they can do it with point to point connections, but they also rewrite their whole applications every 3 years. In manufacturing, stuff tends to be like this, and then you have these spaghetti diagrams, because you will never refactor. And then there's only a third option. Now think it top down, which is, it's called asynchronous message passing. It's basically a message broker, which unfortunately adds a new component, which can fail, which is bad. But then the other side, which allows, so everyone starts talking to the message broker to exchange information real time, and then you put it in a database. So everything has like advantages and disadvantages. But in manufacturing, where the other two choices are mostly not a good way to go, a message broker is top-down thinking the only viable option left and it's usually a very good option. And this is like what we typically try to do. Maybe it's too scientific here, everything, but I also wanted to add a new perspective to that.
No, it always helps when other people provide their own input there. Certainly a picture speaks more than 1,000 words. Really helps me understand and unpack what's there. My favorite part of doing podcasts is I learn so much when I'm on it, which is, again, I can't thank everybody for their time and their participation. So as Kudzai was talking, one of the things that came up was that we want to have these semantic data models. We need to publish them to a defined topic name structure, because if I'm just a device and we all just start willy-nilly doing things, I don't know that we're really ever going to be able to leverage the value of this unified namespace. So, Aron, I think it is HighByte that might have even pioneered the term data ops. So when I talk to people about HighByte and what it does, I say it's a data ops tool. I even mentioned that in my definition. So could you share with us, what exactly is a data ops tool? What is HighByte doing, and why is it so critical to the architecture and design of a unified namespace?
Yeah, sure thing, David. I think I found it back in 2018. I think we looked back and did a Google search on industrial data ops back then, and there were 70 results. And I think now there's 300,000 some odd. So we were talking about it pretty early, and obviously that's changed over time, but still it's a pretty consistent message. So when we think about data ops in industry, the classic example, thinking of use cases I like to give is, I'm a large industrial enterprise. I should be able to have a team of half a dozen folks. I might have 50 facilities. I should be able to have a team of half a dozen folks that have the people that process the technology to manage my data movement from the edge to the cloud and the cloud back to the factory at scale, with the goal of driving the cost of change down to near zero. So what does that mean? Here's like classic examples. So some of our larger customers, let's say you have AGVs in your factory, like autonomous guided vehicles, right? So forklifts driving around, nobody controlling them. A common problem with those is they'll get stuck somewhere in the factory, like they'll just stop. And you need to be notified, and someone needs to go on. This is kind of like your Roomba getting stuck under your kitchen chair, right? So that's a use case, right? It's a very practical one. You have, say, 20 facilities that have AGVs across 3 or 4 vendors. What you do with the data ops platform and that team of 6 folks is you can go in and say, okay, what's the data we need from these AGVs to be able to detect when they get stuck? So you create a data model, right? And that data model is nothing more than, maybe it's its location. Last time it chirped data, maybe it was talking MQTT, and a few other additional bits of information that say this is the data we need from the AGV, regardless of the vendor, to be able to enable this use case. So with data ops, you'd quickly enable that in one factory. We're not talking about months of integration. We're talking about weeks or less. Pipe that data to some system in the cloud. Maybe it's going to Snowflake S3. Maybe it's going through MQTT as part of the UNS. And then what you would do is you'd prove out that use case really quick with the factory to say, okay, can we detect these AGVs getting stuck? Once you've done that, you should be able to take that use case, that data model, and the technology you use to push that data and replicate it across all of your factories, right? All 20 very quickly in the span of less than a month, and enable that use case, right? At the same time, you might find that you tried that use case, it delivered no value, you just throw it away. So it's got data ops is the concept of I'm going to create this process, people, and technology that allows me to test these use cases really quick. And then either scale them out quickly or reduce them. And then once you find, this is part of the UNS story too, once you make this data readily available, people will start to use it, and then they'll want changes to that data. They'll say, hey, we don't need these attributes in the data payload, but hey, could we have these? Or hey, could we scan at a faster level? And the key to data ops is making sure that people processing technology can make those changes at scale at near zero cost. Like that you should be able to add an additional attribute of data, wire that up across all your facilities, and publish that to your end system with very little work, right? So that's kind of the core of data ops. We think about data ops in terms of UNS. The part that applies directly to UNS is that data model, that semantic model. Like you said, if I have every PLC just chirping raw data into the UNS, it's not very usable. Traditionally, factories don't have this concept of like a nice rich namespace with a logical way we think of the factory and that data mapped to the actual data in the PLCs. And MQTT and data ops, and combined with MQTT, is a way to model that data at the edge, to create those models and then move it semantically into MQTT in this example in terms of UNS in a way that a human could come in and look at it and go, no, this makes sense. I can see this is site area line, this is the machine, this is the temperature sensor, regardless of the vendor. So it abstracts away the details and kind of the mess of the different implementations and the different technologies that are at the edge. So by the time it gets into the broker, it makes logical sense.
Excellent. So if I understand, so we now have this broker, so we're going to use MQTT in our example here for this unified namespace because it is fairly common. So I have client instantiated data. I can update data as there's new information available, and I can also buffer that if for some reason there's a loss of connectivity, that's there. The data ops piece comes into what's sometimes called data governance, so that there's going to be we'll call it a data contract between the producers and the consumers of, I'm not just going to willy-nilly publish raw data. I'm going to create these agreed upon semantic data models. That could be the model of, and for people who know me, I always use a pump or a compressor or some type of asset. This is what that payload is going to look like. And then I'm also going to publish it to a topic structure that has already been defined. So commonly we'll use the master data model. There's a lot of references to IS 895 using that hierarchy of enterprise, site, area, line, cell. So we want to publish data that's there. So that's the piece that the data ops takes care of. Is now we have an enabling technology, but let's make sure that we're sending data in a way that everybody can understand. And if I needed to go find data, I would know where to get it. Does that make sense?
Yeah, exactly. And I think data ops and UNS, they overlap quite a bit, right? Data ops is that flexibility to move that data wherever you want. MQTT happens to be currently, a really easy, useful way inside the factory and even out to subscribe for multiple subscribers to come in and access that data. So it kind of gives you that semantic ability, but also the flexibility to move it wherever it needs to go.
All right, perfect. So, continuing on with many of the conversations around the UNS, almost one of the first questions that almost everybody asks early on is, well, is there a database? Where do I store my data? Because if I'm publishing to it, does that mean that the UNS is a database? And actually, no. It's just the current state of the business is the way I understand that. But maybe Jeremy, you can help us understand a little bit about, does a UNS store data, or if it doesn't, then how do you go back in and retrieve some of that data? I'm publishing it all. I'm assuming I'm collecting it, but what does that mean in terms of a unified namespace?
Yeah, so this is also something I already said, like, what's our scientific approach on message broker? And it always sounds a little bit, scientific and like kind of unnecessary, but in situations like this, it really helps in bringing the discussions forward. So I already said, like, there are only 3 ways on how you can connect building blocks. And if you do it via a database, then you don't have this real time. So we already established the unified namespace in its core is not a database. It has a message broker. But then there comes the question, okay, cool, nice. Now I have all my real-time data, but I want to calculate the OEE. I want to have like a historian. Where does the historian fit in? And beside now a lot of practical things in the ideal world, how would it work? You have the unified namespace or a message broker, if we try not to use buzzwords. So there's a message broker. You have this data ops or data contextualization layer, which helps you model everything. And then you have like additional database, so that whatever you have in the unified namespace, you can actually also put it in a database. And there, I think you can go really deep down into like rabbit holes, because what do you want to store? Is it now, because you can send a lot of information through the unified namespace. I would say the most easiest thing is time series data. So you send it through, and then you can define like a kind of like a certain schema. If data is in a certain type of format, for example, this topic, or we in the Unified Manufacturing Hub use like a certain type of data model. We use like _historian. It will then land up in a time series database, and you can apply the same also for other things. For example, if you have like more like an ISA 95 style of information, like work orders, new products, etc., you could store it in a more relational database. There are now some people in the community that try to mix it all together, saying, okay, no, let's also put the database in there, and let's try to mix it all up and put like a graph database in there. But from our experience, it just makes communication very hard. So from our perspective, there's a message broker, which is for real-time data. There's a database, You could use something like TimescaleDB. We've written a lot of blog posts about it with where they have like time series data and a relational database combined in one. And then you have like a microservice or whatever, some kind of component. Could also be the data ops layer, but could also be something else that subscribes to the message broker to these certain type of topics like historian, and then stores it into the database. And this is also something how we've seen most companies approach it. Of course, the exact tools they change, what type of databases, what type of message book, whatever. But this approach is, I would say, if you give it to any IT person, they will look at it and say, okay, yeah, this is boring, and this is exactly what we aim for. Make everything boring. But then now there is like this step between. Okay, what if I want to store data, but not permanently, but only buffer it for a short period of time, for example, during connection outages. And this then gets, I would say, a little bit tricky because it's because you don't want to use a database, because database is you only do it like permanently, but like also MQTT. I've not seen a MQTT broker yet with like a proper queue system in there. We use, for example, Apache Kafka for this as an addition to there. You could also do it in your own microservice that kind of buffers the data in between. But yeah, these are the main considerations. Now we could go into all types of details. I could talk for hours about this, but we also wrote a lot of blog posts about this, so no need to repeat everything here.
No, thank you for that. So if I understand, we're really just limiting the unified namespace in how we're defining it. Is there's not persistent data or storage of data. It's purely just for the pub sub functionality using a data ops tool to make sure that we're bringing in semantic data models to a defined topic structure. And then depending on how you want to query or retrieve that data, that becomes more of a function of what is that you're trying to do. Did I understand that right?
Yeah, I don't know about the last part. Can you rephrase the last part that you said?
Yeah, it's so now the endpoint becomes depending on how I want to consume that data or query that data. That's not something that I'm necessarily going to retrieve from the, say, unified namespace. There's going to be a database or some other piece of technology that's where I go to retrieve the data. It just everything has traversed that UNS so that there's an agreement on what is the data I'm going to find. Is that right?
Yeah, exactly. And what makes it now really difficult is to ensure a consistent data model across everything. I'm still writing on that one article. It's already half published, but it takes really a lot of time because now you have data models in the PLCs itself. Then you have like a data model in the UNS, and then you have a data model in the database. And you want the people still to be that set up the PLC still to be understand whatever happens in the database. So this is something I would say that really challenging to design a data model that works across all three of those components.
Yeah, I think that's a very fair statement. And actually, one of the things that I wanted to talk to Aron about is the idea of, as we're building our data models, so this is very common in programming, we have this concept of inheritance versus composition. So when I'm thinking of creating these data models, I might be inheriting something where I'm a member of. So I'll go back to my easy examples of, say, I'm a pump. I might just have a basic pump model. But some of the assets in my equipment, some of the pumps, they now have more information that is available on them. Do I want them to be a child, if you will, of a pump, or should I just create two completely separate, independent models of this type of data, or do I start bringing other data models and nesting them within an overall model, and all of a sudden now it can get pretty cumbersome and complicated on top of the three use cases that you already mentioned, Jeremy. So, from a data ops standpoint, Aron, how do you generally approach the data modeling in all these various scenarios?
Yeah, I look at it as two extremes, right? You could start really simply and just model the bare minimum of what you need. We see some customers do that. We think they probably have more success, like use case driven, like I mentioned the AGV case. Start there, go learn, adapt. You'll have other customers that'll go to the other extreme, and I would call that digital twin, right? Where it's almost academic, where they'll spend 6 months trying to model the factory perfectly using UML and a bunch of stuff, and then trying to break that back to semantic models. They'll end up with the perfect model. They'll go to implement it, find out it's really difficult, and hey, the end systems can't use this anyway. It has too much hierarchy, or we messed up here. So the sweet spot is probably, it's probably somewhere in the middle in terms of inheritance versus like composition. And we have a whole modeling guidebook. I think we wrote it a year or two ago. That's actually really useful. So I encourage people to go look at that. There's a lot of practical advice there in terms of modeling, which is new to the space, right? So we're all trying to figure it out. But in terms of inheritance and composition, inheritance, we tend to lead towards competition or composition more, not competition, composition. Strict, and this is it's kind of academic as well. But the thing with inheritance is you kind of create a hierarchy as a result of inheritance, right? As you mentioned, David, you have a base model of a pump, and then you derive for the Mitsubishi pump, and then different pump types. And for the audience, when you think of inheritance, you think it's a relationship, right? So I have a car that's my base model car, and then I have a Volvo and a Subaru, and I start to add attributes off those base models. And just kind of build that up, you end up with this implicit hierarchy that's somewhat coupled. And what you end up doing is, if you go with the inheritance route, later down the road, you have to go change some base models, and that might be implications in that across all of your model definitions that you didn't quite anticipate, and that can make changes more difficult. So like the classic example of this, if folks are familiar with OSIsoft, now owned by Aviva, the Pi system, they have a product called Asset Framework, which is over 10 years old now, which was kind of a pioneer in modeling around historical data on a historian. And if you're familiar with their system, they use templates, which are models, and they use inheritance. And if you've ever dealt with a really large Pi AF system, you'll instantly be able to tell why inheritance gets tricky, and that coupling starts to make things really difficult. So composition, is the flip side, is a little more flexible. It just says, hey, I have a model, and I want to kind of inject in that model a set of attributes that are, let's say, asset metadata, right? So the name of the manufacturer of the asset, when it was last serviced, the year it was installed, kind of thing. And you can kind of place that in any of your model definitions that are an asset, and change that set and have a smaller change set across all of your model definitions, because only the things that are composed of that will change. So it gives you some more flexibility. So in my opinion, I think composition is probably the better way to go. But it's a great question. I would also say don't go digital twin. I think digital twin worked really well in building automation because buildings don't change, right? And they're built once, and there's a code and everything's set up. I think when you look at discrete process or batch manufacturing process, maybe not so much, but a lot of data, things are in constant flux. And if you try to design your models around digital twin, trying to perfectly replicate, digitally that physical asset, you're just going to do a whole ton of work, and you might only leverage 20% of the value of that work at the end of the day, given the data you use.
Excellent. So, to me, I've always liked the idea of inheritance, because from a data governance standpoint, it means I make one change and I know that's going to proliferate or federate across the entire system, versus the composition, where I might have to go in and do some other activities. But I hear what you're saying. It's just there's a lot more flexibility. I tend to be more on the composition side myself. It just means, as part of our data governance, is that when there is an updated, we'll call it the best practice, that everybody is responsible who's involved in this data ops tool to update their assets accordingly. Is that a good approach to handling that?
Yeah, and another practical example, you're going to have an injection molding machine that has 2 motors, and then you have one that's 3. You could do that in inheritance, but it's a little easier to do that, model that via composition. The flip side of that is, again, you might not want that level of detail by the time you get up to your cloud system and AI and ML. Because if I'm coding against the data you're providing, and I've got to deal with, well, this one has 2 motors and 3 motors and 5 motors, I might not care. And that just creates complexity for me. So you always have to think about that end consumer and your use case of the data, and provide just enough that's needed to simplify their lives. So pros and cons.
Yeah, very good. Great discussion. Thank you, Aron. So continuing on with the same idea, there's another concept that's known as choreography versus orchestration, and moving this data around. How do we want to ensure that the right data ends up at the right place? So the concepts here are choreography. So if you think of, if you're watching a play or an actual dance group, the choreography is I'm going to do something based off of what somebody else is doing, but nobody's necessarily controlling me or telling me what to do. I have to be paying attention to what everybody else is so I know where I'm supposed to be, what I'm trying to do. So it's very independent versus orchestration. So when you go to the symphony or the orchestra, there's always the conductor that is now providing that guidance of I'm not going to come in or I'm not going to play my instrument until the conductor has looked at me and said, okay, now it's time for you to play. And there's a lot more control over that. The benefit of choreography, of course, is that all my systems can act independently. There's a lot less overhead that's associated with that versus the orchestration where now you have a system that is now telling everything what to do and it has to manage everything. And there's a lot that goes into that. So, in this conversation, orchestration versus choreography, and Jeremy, what are your thoughts on that? How do you approach it? What do you think works? What should you try to avoid?
Yeah, so I think we can approach this topic from multiple perspectives. So let me start with one, and then you can ask a follow-up question. I think the first point is on the topic of orchestration versus choreography. I think you could also rephrase it to kind of like central governance versus edge-driven. And I would even say that orchestration, the central governance, is actually a failure mode for industrial IoT, for big projects, because this is how IT tends to think. You have this, because typically in IT, problems are a little bit different. You have like one cloud, one server, and everything is very close to each other. So what you can do is you can have like one central Git repo, one central database, and from this everything else builds. And I would say it's a failure mode in manufacturing, because in manufacturing you're working with distributed systems. So what does it mean? You cannot assume there's always going to be an internet connection. The connections between all the components are very often very unstable. So you need to go, and you don't want, if the internet connection goes down, you don't want your production to stand still. So in manufacturing, also from security perspective, you have all these demilitarized zones. So and every layer kind of acts as independent from other layers. Of course, if there's like longer outages, let's think about the PLC. If there's longer outages, then there's no information coming in from the SCADA system or the MES system. So after an hour, whatever, it would probably stop, but it could work independently for a certain type of certain time frame. So I would even say that this is a failure mode. So manufacturing itself is very much edge driven. So it's about choreography. Wow, as a non-native speaker, that is a hard word. And this is what one needs to consider. And now there are like different perspectives because the resulting architecture is getting quite complex, because if you're designing a system and you cannot apply these, let's call it these typical cloud IT best principles, and you start doing it, you might not be prepared for the result, because like, how does it look then if you start with choreography? How does it end up? You have a lot of edge devices. Everywhere there could be multiple message brokers. Very often for people in IT, this is kind of, why would you have multiple message brokers? Let's just have one. No, we need every component to act independently of the others. So we're going to have a message broker at least per site, if not even per production line. Then you need to sync between it. And now you can have a lot of different problems that arise from this architecture. I mean, the first thing is you could argue, okay, maybe let's just streamline everything. But I would say, maybe you can comment on that. I think it's not possible to streamline that in manufacturing, because everything is built to be edge-driven. So if you want to work with that, you're going into distributed systems, and there are a lot of challenges that arise out of practically that a lot of people also ignore, but as soon as they start to scale out, they realize this. Just one example in the terms of data flow is what type of data you're sending through the system. So now imagine we have a message broker for each production line, we have a message broker for the site, and then we have one in the cloud to gather all the data. If we know the multiple cases that you have there, for example, if you have like time series data, it's really important that, let's say, 99.9% of the data arrives then also in the cloud. If there are internet outages, it's important that it's buffered so that you never lose any of the data, that it's also stored to disk, whatever. But also, to be honest, it is acceptable if sometimes data points get lost. So if you send a data point every second and then it gets lost once, okay. But to be honest, I think a lot of people have this problem, but they simply don't notice because it's fine. But then when you talk about things like adding a new order or sending commands, for example, in the cloud, you have a button, you want to press a button to start a machine, then things start to get complicated because how should the system now behave if there is no internet connection? You don't want the command to get stuck somewhere and then execute, 4 hours later. So this is what makes choreography so difficult. And what we do at the manufacturing hub, we try to build a product that gives you the overview over that. So you have all of these instances, you have all of these edge devices. So we give you a single view that allows you to see the health of each of your nodes, the health of each of your network devices. So in case something goes wrong, you're notified about it, and you don't have to go through hundreds of VPN tunnels, jump hosts, whatever, just to go to that edge device just to check that the problem is somewhere else. But now I'm stopping with a monologue and giving over to you, David, for any follow-up questions. I hope this was what you asked with this choreography versus orchestration.
Yeah, no, thank you for that. I tried to pick words that were going to be very difficult for you to say, and I'm glad I was successful with that. Yeah, so your comment about the orchestration versus the choreography is you were talking about the pitfalls, especially if you do a full-blown orchestration where it's the command central in that governance. I wondered, maybe coming back to, we'll call it the Goldilocks principle, can there be a balance? There's going to be some systems that are choreographed, but other systems that are more orchestrated, because we want to have more control over that data and understanding what's going on, type of thing. Would that be a good approach? Maybe try to keep it as choreographed as possible, but add orchestration as needed?
Yeah, so what we try is try to bring both worlds together, because in the core it needs to be choreography. So everything needs to work independently of each other. But on the other side, just from a maintenance perspective, you don't want to have all this chaos. You want to have a central view. You want to have something like Git and GitOps to configure it. So you need to meet in the middle. Our current hypothesis is the data infrastructure needs to be distributed. Easier word to say. Needs to be distributed. But then the configuration of that can still be centralized, because it's also, you're not having so many problems with it. So that would be the current hypothesis on where the trade-off needs to be.
All right, excellent. Thank you for the follow-up on that. So another question that we get asked a lot, and I think, Kudzai, you can speak to this, is some of this conversation around inheritance and composition or orchestration versus choreography. I need to know that my message made it to where it's intended to be sent. And while we're not here to design a point-to-point per se, I want to know that if I have a change that is relevant to some other system, there needs to be some assurance that that message got there. And what comes up oftentimes is, specifically within MQTT, is this concept of your quality of service, or your QoS. So while QoS 2, as it's known, will ensure that the message made it there, my understanding is that is really just between the relationship is between the client and the server, not necessarily from the client to the other client. So can you just talk a little bit about just quality of service in general, and the implications of it? And then for those, we'll borrow from the FedEx, absolutely positively overnight, the message has to get there. What does that look like in using QoS2 between two clients?
Okay, perfect. Yeah, so I mean, same applies. That's the same question that we get a lot from customers. Really, some of them wanting to send commands over MQTT. And just before I go into the QoS, is most of the times we basically tell the customers that if you need to control your robot, like if you need to perform some kind of closed loop process control, you're better off using OPCA or some other field level kind of like a protocol, because it guarantees you that synchronized communication where you get the response, immediate feedback about what's happening, and there's in some aspects some attached to it, which is really perfect for that kind of scenario. So MQTT is really not built for sending those critical commands or messages, right? So as far as quality of service is concerned, yes, you're 100% right. The relationship between of the quality of services between the client and the broker. So with quality of service, the broker guarantees the message delivery to the actual client. So what that means is that when the publisher sends a message, it will get the acknowledgement that this message has been received by the broker, and that the message has been sent to the client. And now, but what happens after the message is handed over to the client is not something that you get within the MQTT framework. So this is something that would typically be addressed like in a direct point-to-point protocol, right? However, with out of service, there is the guarantee that even when the network fails during that exchange, all of the clients that did not receive that message during that network disconnection, the broker will follow up with all those clients and make sure that they do send acknowledgements, and then that acknowledgement is sent back to the publisher or whoever is interested in knowing what acknowledgement has been sent. So that information is not lost, right? So the quality of service guarantees you all of that information as long as you are using persistent sessions, right? But again, if you want to control a robot, or if you want to get data out of a database and search through what happened through such and such a date, you are better off connecting directly to that application, and then that snapshot of information, that view, you could then publish it to the MQTT unified namespace for all the other components that might be interested in that result. So the MQTT is only just for the real-time events and state of your entire enterprise, and not for transactional kind of like interactions.
So, following up on that, what Kudzai just said. First of all, because please believe me, I studied mechanical engineering, so I studied the vibrations that are caused by CNC machine milling screw somewhere. But I realized that sometimes referring to scientific IT literature and taking a look at, hey, how do these big companies, how do they solve it? That really helps. This question of quality of service, I think it's really interesting because it is also, the paper is actually from 2012. It's actually already kind of like a solved problem. So what quality of service means is it guarantees you the communication between the client and the broker, that it's only once, but still it doesn't guarantee you that through the system, for example, if you have one message broker that from one client, it actually lands up at the second client. Or even if you have like multiple message brokers that actually lands up through multiple brokers, it's bridged to the cloud, whatever. It doesn't guarantee you that. So you always need to solve this on the application layer. And it's not the problem of MQTT. It's just how IT protocols work. Because even in the underlying fundamental part, even TCP, even there, you have this concept of resending messages. But it only goes from like the network stack of one device to the other network stack. So if anything gets lost there, theoretically, there's already a retry mechanism in there. Also MQTT. So every layer on there has come up a retry mechanism, but still in MQTT, there's still the option that the message gets delivered somewhere. For example, gets delivered to the client, but something goes wrong between the delivery of the message and the actual processing of it. And how we typically solve that and how we can send commands through the system is by designing giving the message a certain type of payload to actually to be and to design a protocol on the application level to actually ensure that some of the problems don't arrive. For example, you would have like some kind of like command, a request and response mechanism, even through MQTT, if you really need that assurance that something was really executed. Maybe we can link the article further down. It's this one here. It really helped me. I'm basing one of my blog articles on it. It really goes very well into the details of exactly this quality of service discussion. So if anyone is having exactly these types of thoughts, I can definitely recommend going into this article here.
Yeah, you shared that article during our conversation about this, and I found it exceptionally helpful because, I guess coming full circle on everything that we're doing. One of the questions and the struggles that I have had is that we've always talked about this unified namespace for, both for the data and the events and transactions. And to me, these events and transactions are these are asynchronous, and it's not like, say, time series data that's just constantly flowing in. It's as we talk about events, it's either the car arrived somewhere, that's an event, or you could put an event frame around we had a production time or a downtime, or there's a shift. There's an event it could be there's time bound. That's another aspect of it. And then, of course, there's transactions that are at the end of those events or beginning of those events. There's certain payloads that publish things off. So, maybe as just a last question in general, is a UNS really geared for time series data, or can it be used for events and transactions? And if so, what is the best way to approach the events and the transactions to that? So at this point, anybody feel free to chime in on just thoughts around that idea.
I think I have the feeling that the UNS is suited to some type of degree, also for events. For example, and you need to have it like this. For example, like start a production machine, etc. But sometimes, I'm still investigating this. But my gut feeling tells me the more complicated it is, the more it's better to have it in a different type of system. For example, let's call it. One example, a state machine is, for example, want to enforce that the production is always in a reliable state. So that means kind of like a line PLC or kind of like a SCADA system. So you can use the UNS as a communication through everything. So send a machine command, and you can show with the techniques that I mentioned that data actually arrives there. But who is taking care of the state of the overall production line? So what do I mean with state? Machine is starting. So when the machine is starting, in order to go from the starting state to the started state, it needs all PLC must respond with a certain type of command. There must be reset, whatever. This type of logic or events or something is much better suited in an external system, because the UNS cannot handle this state thing. So this is but you can use the UNS to send this information through it. I don't know if it makes sense. Maybe others can chime in. Or you have some more experiences in this regard.
Yeah, I think it's going to be a topic that certainly gets discussed about on future podcasts. So we are a little long on the podcast. I do apologize. I believe Kudzai, you need to head out real fast. Just any final closing thoughts that you have? I mean, we started off, let's define a UNS. Do we think that we've achieved what it is we set out to do here?
Absolutely. Thank you. Yeah, I think we did. So I'll just quickly go through some final thoughts that I have around the unified namespace and also the idea of events and transactions. Again, just to reiterate that MQTT is a protocol that gives access to the real-time events and the state of your enterprise. And it's not so much used for controlling, say, robots or accessing the database, right? That needs to be handled outside of the unified namespace through a direct connection to the database or to a robotic system using a field bus protocol or REST API endpoint or whatever the case may be. So MQTT holds that current state of information, and using features such as retained message, it makes sure that you've got your unified namespace always living within your MQTT broker, not as a database, but just as that snapshot that whoever joins the network is able to discover what the current state of any component that is connected to the unified namespace is. And if the network happens to disconnect on any one of the clients, that information is persisted, but not as a database, again, just as a mechanism to make sure that that information is redistributed whenever these different components rejoin the network. For the database connectivity aspect of it, we spoke about it earlier. Like, for example, HiveMQ, we provide a connector that allows you to persist all of this unified namespace. So you could, say, select different namespaces that you want to consume, whether it's going to, say, a Snowflake, and you want a certain namespace that you want to persist to that. You use a connector that allows you to do that. If you want to persist data to a MongoDB, there's a connector that allows you to do that. Or if you just want to hand it over to Kafka, there's a connector that allows you to do that. So MQTT itself doesn't persist, but it gives you a mechanism to be able to persist your data outside of the broker. And then just lastly, on the idea of orchestration and choreography. So I mostly like to think of it as it helps to look at unified namespace as a way of sharing data rather than collecting data, because I think we've been accustomed to this idea that data is a byproduct that merely needs to be collected. But it's a mindset shift where you start to look at as this idea of having to share data, which really encourages, say, the domain or owners of that data to actually package it in a way that it is usable on the other end, because now it is being shared rather than just being made available for collection. And it's kind of like a mixed compromise where you've got the central governance and you've got this distributed approach to it. So it's a balance that needs to be struck there.
Yeah, so it sounds like there's just a lot that goes into a unified namespace, and the ways they can be approached, and just depending on the use case, really will indicate of how you go about and actually developing the formal architecture to that. So, Kudzai, if you need to drop, please do. I do appreciate your time. Thank you for that. But before we sign off, Aron, we're talking a little bit about time series data versus events and transactions. Any thoughts that you'd like to offer on the topic?
Yeah, I was just say hats off to Kudzai and Jeremy for their talk. I think just to say MQTT, don't try to do transactions through there, don't try to do commands. I think is a message we kind of need to deliver to the broader market, and it's good, refreshing to see that, because early days of UNS, it's even on the Discord channels and stuff now, people trying to figure it out, and it's like, just don't do it. It's not, in most cases, it's not the way to do those. The point-to-point connections, what's interesting there, if you need to guarantee the data is going to be delivered to S3 or some other source and you're running it through MQTT, can you kind of hack it using the client IDs and stuff to say, hey, if this client drops, then start to store? Yeah, you can do it, but it might be a sign, again, that data, you might want to send that data an alternate path, right? Maybe that should go to MQTT, but it should have a direct connection to S3 or Blob to guarantee that delivery. So what I think is interesting is UNS is, I would say, caught fire, right? It's definitely here to stay. I think MQTT is a core component of that for report by exception. But, all these conversations and confusion is really the market saying, this is great, but what about this? And what about this? And what about this? Because we have slightly different use cases in manufacturing. MQTT designed for oil and gas. The protocol itself doesn't encompass all of those. And Kudzai was very honest about that, right? And I think that's great. I think MQTT is a core part of UNS. I think the interesting part is, how does UNS grow? How do us as vendors and technologists support our customers to enable these other use cases through best practices? And I think, David, it'd be interesting to come back in 6 months and be like, okay, what did we say that was right? And what did we say that's now changed? I think it is moving that fast.
Oh, interesting perspective. I hadn't thought about, we could revisit this, and what I said at the beginning of this call is, well, actually, that's not what a UNS is. So, and I think that's maybe the struggle, is that we're still aligning ourselves on what's the technology and what's in the approach, because the intent is that we want to create these data-driven organizations that, we have access to all of that data in real time, and we can use that for solving problems, whether it's some type of, I want to do an asset health, and I want to be able to, say, predict the failure of a piece of equipment and that type of thing. And what does all that look like? So before we sign off, Jeremy, any final thoughts you wanted to share with us?
Yeah, just to that the opinion that I stated is clear. So I said that it's fine to send some commands through the UNS, but for like more complex things, it's probably not that well suited. But you can also, for controlling the production, you can still use UNS, but it's not that intuitive to do. And just sending messages through it, there's a lot of complexity behind it. So if you're unsure about whether to do this or not, I would tend to say probably for now. Also hearing also the others are even more skeptic. They're saying, first understood, please don't use the UNS for setting commands. So now I'm here saying you can use it, but be careful of what you're doing. And otherwise, if you like what I'm talking about, you're always free to check out our content, our blog articles, our learning hubs. There's a lot of information if you ever want to read about this in detail.
Excellent. Yeah, thank you. And really, all of the Kudzai was talking about Industry 4.0 TV, or the HighByte website, and certainly the UMH, Jeremy. There's a lot of great content about things to think about as far as we're doing this. So at the beginning, I defined the UNS as it's an approach to an event-driven architecture that utilizes a pub/sub technology like MQTT, along with a data ops platform, so that we're creating semantic data models and publishing it to a defined topic structure. It seems like there's a lot of other considerations in terms of the composition versus inheritance, or orchestration versus choreography. Then taking advantage of some tools that are in there, but just make sure that what tool you're using is the right tool for the job. Well, thank you everybody for your time, and I want to thank the other people that were involved in all these conversations as well, because it's certainly something that I'm trying to get my head wrapped around. But thank you everybody for your time. I look forward to seeing you on our next podcast.
Thank you. Bye.